Hi YouTube, this is Peter J. Hopkins. Welcome to my next video on solving Rubik's Cubes. In this video we're going to discuss how to solve the 4x4 cube, otherwise sometimes known as Rubik's Revenge. There are a few differences that you need to know about solving a 4x4. First of all, we don't have any centers. I'll get to that in a little while, but you sort of have to make your own centers, and that's the process. First you solve the centers, then you solve the edge pieces, edge pairs. I think of them on the 4x4 because there's two apiece. And then, at that point, you can basically solve it like a regular 3x3 cube with a few weird little differences that we'll get into called Parity, which makes things a lot harder and a lot weirder. So, let's talk a little bit about the notation for the cube, algorithms for a 4x4 cube. It's basically the same, except for a capital letter, like a capital R, for example, would just be the outermost R face. A lowercase r would be sort of the inner R face, same as any other face. So the little f would be the inner F, inner front face. And then a star would mean to turn both together. So R star would be that, L star would be that, where you're turning both the outer and inner faces on that side of the cube together. That's basically the only difference in how the algorithms are written, how the notation works, so you need to learn that too. Before you get started, if you have not scrambled your cube yet, good for you, because it'll make your life a lot easier. You want to examine your cube and memorize or write down the relationship of the faces to each other. On a standard Rubik's Cube, white and yellow are going to be opposite each other, green and blue are going to be opposite each other, and orange and red are going to be opposite each other. If you're using something other than a standard cube, that's all probably going to be different. But because you don't have any centers, you're going to need to know the relationship of the faces to each other before you start, because otherwise it'll be very difficult to get started. You'll have to figure it out on your own. So let's scramble this cube up and then we'll discuss it a little further. Okay, now, if you are starting with a scrambled cube, you're going to have to figure out the relationship of the faces to each other, which is a lot harder if this cube is scrambled. But what you need to do, because you don't have any centers to tell you what color each face is supposed to be, you have to figure that out on your own. You need to look at the corner pieces, and it's a lot easier to do this if you have a piece of paper. You can write it down, you can sort of draw a diagram or something to help you out. But you look at the corners, like for example, I could look at this corner and I would know from this that yellow, green, and orange are in this relationship to each other. It's a pain in the butt to figure it out. It's a lot easier if you write it down, but it's easiest if you figure it out before you even scramble your cube. So keep that in mind. If you're starting with a brand new cube that is not scrambled, good for you. It'll make your life a lot easier. Now let's get into actually solving it. Because we don't have centers, the first thing we want to do is we want to solve our centers. You can probably guess what the next thing I'm going to say is. I always start with red. And you want to, first, you sort of get a couple of them lined up. That's not too hard. Then you find your other two center pieces, and you get them lined up, and then you sort of put it all together. Your first center should not be that difficult to solve. If you've been solving the 3x3 and the 2x2, which, by the way, I recommend that if you haven't watched the 3x3 video yet, you do that. Again, you need to know the basic skills for solving a 3x3 cube before you tackle a 4x4. So if you just bought your 4x4 and you're trying to learn it and you're watching this video, stop it right now, go back to the 3x3 video, watch that one, learn how to solve a standard regular Rubik's Cube first. It'll make this a lot easier. You have your first center, you just put it together. I can't really tell you much more than that. Just figure it out. It's not that difficult. Then you want to solve the opposite center. So you flip it over, you just did a red, I'm going to do orange now. Okay, so I looked out, I have a couple that are lined up already, and what you do is, you take the two, you put them sort of vertical. You flip it up onto the top. Then you flip the top around and you pull the ones that are not solved down. And that'll resolve your face that you did first. And it'll get you a pair up there solved. Then the next thing you want to do is line up by just moving. You should be able to do this just by moving around the center layer. And if you move the other faces, it won't mess up the center because the faces don't affect the centers like that. So you want to line up your other two, and then you get, this one freezes up sometimes, you get them in a straight line. See how I have that? You get them in a vertical line with each other. You put this one in the top layer. You can see the red right there. Turn the top layer around and then flip it back down, and it'll solve the rest of it. Okay? So that's how you get those two faces, the opposites from each other. Now you turn it around, and this is where it can get tricky if you didn't memorize where your faces go. You have to solve the other four. At this point, I usually do blue. So here I have two lined up already on my blue face. You want to get those horizontal. And then you look for the other blue pieces. In this case, I have one right here. Flip it around so that they're lined up. Then in it goes. Your first face in the sort of the middle layer like this shouldn't be that difficult. Next, I usually do white. In order to keep from messing up the blue face, which we've already solved, you're going to have to think ahead a little bit. So this is what I do. I think of it as like the pieces that I've already solved, sort of pulling the pieces that I haven't. It's not really thinking in terms of algorithms, it's sort of just thinking ahead. So for example, I want to put this white piece over here so that I can complete half of the white face. So what I do is I shift the blue face over one, then I take this and I flip it down so that when I put it back, this white piece will line up with this one. These line up, this lines up. Then I make that one horizontal, and I look for my other white pieces. Okay, here's a good sort of little problem to solve. I want to get these two lined up. So what I do is I move one of them onto a face that I'm not worried about yet. Then I rotate it so that it'll line up with the other white piece. Then, it's sort of similar to what I did with the red and orange earlier. I put it in the same layer as the one that I already solved, and then I sort of flip the blue face around so that when I put that one in the other layer, it'll line up. This is something that's difficult to explain with words. If you experiment enough with it, you'll figure it out. It's not that hard. Solving the centers really isn't that difficult. So here we have another situation. Then I do yellow and green is the last one. But the last two faces, you sort of have to solve them at the same time, which makes it a little weirder. So let's use the same kind of ideas. I want to get part of the yellow face solved. Then I line it up so that when I rotate this layer, it'll line up with that one. Line it up and in. It's something that you're going to have to experiment with and mess around with to figure out exactly how to do it. It's not that difficult to get the centers solved. It's just practice, trial and error, and you will figure it out. It's hard to explain it, but you can do it. It's not that difficult. The next step is we want to get our edges solved, and there's sort of a process you use for solving the edges. You want to find the two that match each other. So here is blue and red, blue and red. Then you want to take them and you want to line them up just by rotating your faces so that they're kind of next to each other like this. See how one is over here on the right, one is over here on the left, and then you cut the cube through the middle, sort of like that, and you want to make sure that a scrambled edge is up on your top of your front right there. So here's the one we just wanted to solve. We flip that one up into the top. Then we take the scrambled one, replace it, pull it back, and then put the centers back together the way they're supposed to be. And here's the one we just solved on the top layer. And you just do that process over and over again. Okay, so here is blue and white, you just rotate your faces until they're lined up the same way. One's on the right, one's on the left. And by the way, it wouldn't matter how they were lined up. See, now this one's on the top and this one's on the bottom. It doesn't matter which one's on the top or bottom, just as long as they're sort of across from each other. And in fact, they can even be all the way across the cube from each other. They don't even have to be next to each other. But I like doing it this way so that I can see which one is where. It's a little bit easier. Line them up, flip it into the top row, replace it with one that's scrambled, flip that back down, and boom. Here's the one we just solved. And you keep doing that process. Can never see. Okay, here's one. See, this one's all the way on the other side of the cube from that one. It doesn't matter. Just as long as I get a scrambled one in the right spot and replace it with it and then flip it all the way back around, it's still fixed. Okay, there's another algorithm that you want to know for solving the edges, and it's a shortcut. If you have two edge pieces that are with each other, sort of like a mirror image. See, orange and yellow, orange and white, orange and yellow, orange and white. And this side, these edges, look sort of like a mirror image of these edges. There's an algorithm you can use that will solve both of those at the same time. And it is D star, R, F prime, U, R prime, F, D star prime. And it'll solve this one and this one at the same time without having to do them separately. So that's a nice shortcut, and when you get towards the end, you may end up having to use that one if your two last edges are both scrambled in that relationship to each other. I decided that it was important for me to actually know the algorithms off the top of my head if I was going to be making these videos, so I didn't look like an idiot who didn't know how to solve the cube. So I practiced it and memorized them beforehand, or re-memorized them, I should say. Like I said, I knew how to do them. It's just that I have a tendency to forget the numbers and letters and just rely on the muscle memory of my hands. Okay, there we go. All of our edges are solved. The next thing you want to do is solve it just like a regular 3x3 cube. So we have our centers, our edge pairs, which function as single edges, and our corners. And that's what you do. So I start with red. I'm a creature of habit. I like red. Red's my favorite color. It's awesome. I don't know. Sometimes I wonder about favorite colors. Like, what is it? Like, what is it about red that makes me just like it, but, you know, someone else's favorite color might be blue or green or something. Why me and red? That kind of thing fascinates me. I'm interested in that. It's weird. By the way, if you got your centers' relationship to each other wrong, at this point you would probably start to realize that things weren't going together properly, and you would have to go back and redo your centers, which is a possibility. I've gotten them wrong, even though I've solved this thing a million times. I still get them wrong from time to time just from not paying attention. Just solving along. You'll notice I'm using my little sort of shortcut there for the edges because it's a lot easier than trying to solve them the hard way. Always look for shortcuts. For me, that's really the joy of it, is looking for shortcuts rather than trying to solve it fast. I like to look for interesting little ways of fixing it. Okay, now, here's where things get complicated. On a 3x3 cube, there's only a specific number of ways that this last number of edges. At this point, we have everything else solved. At this point, you'd want to get the edges on your last face solved. And you would either have a center... Darn telephone. Okay, for the purposes of cubing, parity just basically means a situation that can happen on a larger cube that can't really happen on a standard 3x3 cube. In math, parity has a different definition, or a more complicated definition, I should say, and I don't need to get into that for you to understand that. That's all parity means. It's a big word for a simple concept. It's just something that can happen on a big cube, can't happen on a smaller cube, that usually requires a long and complicated, annoying algorithm to fix. That's all parity is. So at this point, on a 3x3 cube, you would only be able to have either a center all by itself or a line, a straight line, a horizontal line, or you would have the dog leg that the fur earth algorithm fixes. On an even cube like a 4x4, that's not the case. You can have any various number of arrangements, and you can see that this, where you just have the center with one edge lined up with it, that would be impossible on a 3x3 cube. This is called parity. This is the first parity case that you're going to have to solve. And in order to solve parity on a 4x4 cube, in order to solve this particular kind of parity, you have to memorize this really long, awful algorithm, and I'm sorry that I have to do this to you. This is the worst algorithm you're going to have to learn for cubing, and it's the one that I forget the most often because I'm bad at keeping this one in my head for some reason. You hold it so that the edge you want to flip, basically, I want to try to get the horizontal line here. I want an orange horizontal line all the way across. So I hold the edge that I want to flip around, see the orange and yellow edge here, in the front top like this. And the algorithm is, okay, so you'll notice from the video there's an edit here. Yes, I messed it up. Yes, I had to do it again. Alright, so it's 2R star, 2B, 2U, L star, 2U, R prime star, 2U, R star, 2U, 2F, R star, 2F, L prime star, 2B, 2R star. And if you did it right, you won't mess anything else up, and you'll have this nice, beautiful horizontal line on your last layer, and everything will be great. Okay, so the whole point of doing that algorithm is to create a situation on your last layer that would resemble a 3x3 cube. You don't necessarily have to get a horizontal line. You could make the dog leg, you could try to make the cross all at once, or if you just had one, you could flip it around and have just the center. But the goal is to create a situation that's similar to a 3x3 cube, and then you can solve it just like a 3x3 cube from there until you get to the next parity case, which is the next thing I'll cover in this video. Okay, yay, now we also have the other kind of parity, which is you will get to the end and you will have two corners in the right spot and two corners in the wrong spot. See, we have our blue, orange, and yellow, and our blue, orange, and white, and they're flip-flopped. These two are correct, these two are not. Again, that's something that's impossible on a regular 3x3 cube. And so, to fix this one, we use what I affectionately refer to as the FU algorithm. And it's F prime, U prime, FU. F, R prime, 2FU, FU, F prime, U prime, F, R. Now, you'll notice it solved our corners. But now, by the way, when you do the FU algorithm, you want to make sure that you start with the corners that you want to flip in the top front position, right where they're right here like this, okay? I forgot to mention that earlier. Now we have these two edges are flip-flopped around. There's another algorithm that you have to use to solve the edges, but it's also pretty easy to remember. It's 2 little r, 2u, 2 little r, 2u star, 2 little r, 2 little u. And that'll flip around those, and at that point all you have to do is solve the rest of your edges.
Corners,
and everything will turn out fine. And there you go. It's solved. Great. Awesome. Okay. There's a shortcut that you can use in solving the 4x4 that I really like. I use it a lot. It almost guarantees that you will end up with one kind of parity, but it will allow you to get through that parity very quickly almost every time. So this is how it works. And again, if you don't want to use this, you don't have to, but it's up to you. You get the cube to the point where you have your cross, you have your two edges that are in the right spot, your two edges that are in the wrong spot, but instead of holding the edges that are correct in the back and right positions, you hold the two that aren't. See, I have my green and my white flip-flopped around, and you do the right, up, right prime, up, right prime algorithm, and you'll end up with two edges that are correct and two edges that are incorrect. Your goal is you want to get two corners that are correct on the same side as an edge that's incorrect. Alright, so what we have here is we have two edges that, or two corners that are correct here and here, two corners that are incorrect here and here, and we have two edges that are wrong. And you can use the FU algorithm to solve all of this at the same time. So once you get it into this position, F prime, U prime, FU, F, R prime, 2FU, FU, F prime, U prime, FR. And that algorithm will solve both your flipped edges and your flipped corners at the same time, and it'll sort of save you a step. The problem is that it almost guarantees that you end up with some kind of parity, because if all of your corners end up in the right spot, then you still have the two flipped edges to end up with a case like this where your corners are on the right spot, and you can just do the algorithm I just did, the 2 little r, 2u, 2 little r, 2r star, 2 little r, 2 little u. Alright, that's basically all you need to know in order to solve a 4x4 cube. I wish you good luck, I hope you enjoy it, and I hope to see you in the next video. Bye!